Hello everyone and welcome to our second video in our hinge example. In this video we're going to finish up our hinge object by making the second plate with the two connectors that are kind of like the inverse of these three, and we'll also make the pin that slides through all five to join the two pieces together. And so the first thing we're going to do is remember that we actually made both rectangular bodies in the original time, and so we want to make sure that we bring back that second body, and there it is. We can see that it's a separate body even though it overlaps with this one, so we're going to do some adjustments as we go. I'll hide body 1. Sketch 2 kind of let us know that what the size of our circles were. This was an 8mm circle with a 5mm inner diameter. And we also added this extra line so that we could cut out or merge this piece in our thing. And we're going to make sure we do that in our new sketch as well. So I'll hide sketch 2 one last time. We'll start off just like we did last time, sketching on this side surface. So it turns blue. We'll create a new sketch. It gives us our side view. We'll make a circle with our circle tool or C on our keyboard. Somewhere on this line I want a circle. It doesn't really matter where, though I don't probably want to put it on the midpoint so it doesn't get stuck there. I'll put it just somewhere along. The first one is 8mm, so there it is, 8mm. I'll do another one, so C on my keyboard. This one should be concentric, so I want to make sure to use the same center point wherever I placed it. This one should be 5mm, and there it is. Notice they're both blue because if I drag the center, they can both move. They're not really stuck there. How do I know where this center point should be? Like last time, we didn't really calculate a number. We simply used the tangent constraint to snap to this bottom line. So we'll do the same thing here. So I'll select the outer ring of this circle. I'll choose the tangent constraint from the constraints menu, and then choose the bottom line, and we'll see that it snaps. Notice how the circles turn black. There's nowhere else for them to go, so they're locked in place, which is fantastic. We'll create a line with the line tool. It's going to be a vertical line, so it doesn't really matter where it is right now when I select it. I make sure it's straight down. You can see that right angle little blue square at the bottom, so it is a straight line. Notice the line is blue because it's still technically free to swing side to side. And then we'll once again use the tangent constraint to snap this line to this circle. And of course the line moves because if the circle is locked in place and all black, it means it cannot move. Then the line was the only thing that was able to move. And now they're all black, so everything's in place. So our sketch is complete. Let's finish our sketch. I do also want to do what I did last time, which is to scoop out both this portion and this portion. All of this should be gone because the idea is that this whole part will be replaced. Well, this part will be empty, and this part of the ring and this part of the circle will actually be part of the where the other hinge merges, so they actually should not both be existing at the same time. So we'll make sure we do that in a moment. So I select both of these things and this last piece, so all three, so the inner part of the square, the ring part, and this outer part. I'm going to extrude. I can drag a little bit, and there it is. And I'm going to make sure I switch my distance, my extent type from distance to all, and it cuts all the way through. There it is. Now this looks like it's just a flat surface, which is okay, but I want to bring back sketch number 4 so I can refer to this part of the ring as we go. And so I can just show you real quick body 1 overlapped, and now this is what I wanted. You can see that the idea is that there's nothing here so that this hinge can swing down 90 degrees down and then 180 degrees the other way. So it has really a rotation of about 270 degrees around, which is really what we wanted. So now that's the case, I can hide body 1 more time. And now my extrusion, and so what I want to do is extrude the solid part, which will be both this part of the ring, this part, and this part as well. But that's only for this side. Now if I extrude this again all the way through, that's going to be blocking or overlapping with body 1, so I actually want to offset the distance of this a solid part of body 1. So I don't want to actually overlap with this piece, so I should start at this ring right here. So I'm going to do my extrusion with my E on my keyboard. I could drag and notice how it automatically does this immediately as a solid piece, but that's not what I want to do. I do know the distance is 20, so I can go to 20 if I like. Negative 20 because I am going inward. And then I want to offset it so it shifts by some amount. And again, if the other hinge has a 20mm long connector, then this one should be 20 offset. So we're going to switch our start in our extrude from profile plane to the offset, and our distance will also be negative 20mm. And there it is. And we can see that even though the sketch is here, the 3D modeling begins 20mm off. And there it is. And notice it is a join because it should be merged with the actual surface. And that's what we want. So click on OK. And so there it is. We can see that first piece. And now finally, if I bring back body 1, we can see from the perspective of the top, it looks like they're perfectly seamless, which is what we want. And on the bottom, we can see that both of these have the same concept, or there's this gap so that when the rotation happens, there's no pinching parts in any way. So now the last step is, of course, to finish this second one, and we can do that as well. So again, we have some choices. I'm going to hide body 1 for a moment. Could I do the same thing? I could offset by 20, 40, 60, 80, and then go 20 across, and that would be okay as well. Or I can simply maybe try using that rectangular pattern to make this whole object go some amount as well. So we'll do that, and that's what we did in our last video, so we'll do it here as well, just to be consistent. So I'm pretty sure I can hide sketch 4. I'm going to use that rectangular pattern tool, not inside of a sketch, but just out in the open 3D world. And so if I choose that rectangular pattern, there it is. It asks me, well, what do you want to do? If it's on bodies, you can always change it to features. Body is the entire object. Features are subcomponents where it's like intelligently figuring it out. And so features is what I want. And hopefully it recognizes, there it is, one unit. This is all one feature. This little connector is one feature of the entire body. And then our axis, what axis do I want to do it on? I can use this green one because it is going that direction. And it asks for 2, but really I don't care about the second dimension. And you can see by default it says that there are going to be 3 of them. So if I drag the arrow, you can see that it says, oh, I want to place 3 of these things. We don't actually want 3. We simply want 2. So I'll change quantity to 2. And there it is. And then now how much do we want it offset by? And so notice some things. The distribution is spacing. If you have it on extent by default, the distance is like how far apart are the centers. Or sorry, not how far apart, but like what's the maximum distance of the total amount between them. Instead, we want to change it to spacing and saying this number represents how much space is between the centers. And so this thing is 20 wide. I want a gap of 20, and I want it to be 20 as well. So the total distance between the 2 components or features is going to be a total of 40. And then axis 2 we're ignoring because we're not really making these hinges in any, or the connectors in any other direction. So here it is. I'm going to click OK. And there it is. Notice still 2 bodies, only 2 connectors now merge with this one. If I select this whole thing, and here's the final result, the 2 hinges, and there they are from the bottom. You can see that they each have this little gap so they can spin freely, which is what we want. So our 2 hinge parts are there, but of course if we printed these and we put them near overlapping, that would be wonderful, but the reality is they would not necessarily stay together. So the last stage I mentioned was to make the pin that does this. So we're going to make that pin, and so I'll make yet another sketch, and the reality is this thing is purely a matter of like, well, what do I want, where do I want to make it? I can in fact choose either surface. I'm going to choose the surface because it does include the circle on it, so I'm going to select it, and I'm going to make a new sketch there. I'm going to zoom in. I want this essentially the circle. If it were perfect, if we had a machine that did metal machining and it was flawless, then we might have no actual difference between the inner diameter of this circle and the diameter of the pin. However, because we are going to use a 3D printer and the plastic heats and cools, it's never exactly perfect, so we should always have some kind of threshold. And in fact, even professional machining tools also have some kind of threshold of perfection where there has to be like a tolerance of how much difference there is, even if it's very, very small. For us, in my experience, about 1/10 of a millimeter in difference, or maybe 15/100ths of a millimeter in difference, is enough to give us grip that they hold on to each other, but they're not too snug where we can't slide it through. So we'll make sure I'll do about 1/10, and I think that'll be good. So we're going to do a circle, and then I can use, in fact, you can see that it gives me kind of, even though there's nothing there, it kind of gives me a blue circle. It says, that's the center point, because it recognizes that's the center point of the 2 circles that we had chosen before. And so I'm going to do this. And so I know that if I go to this line, it would snap to 5, and I said I want it to be 1/10 less. So instead of 10, I will do 4.9. So I'll type it in here just to make it a little bit easier. So 4.9, and there it is. And so there is, in fact, a gap between these, so you can see that that's 1/10 of a millimeter, which is not a lot, but it is there. And that's all I'm going to do in this sketch. And so there it is. And the last step is to extrude this as one piece, essentially to be the final pin. So I have that inner circle selected. And again, just to be clear, make sure you do not select the gap between them. I know it's kind of hard to zoom my camera in, but this inner gap between these 2 should not be selected. It should be only the inner ring. I'm going to hit E to extrude. And you'll know that it worked correctly because you'll see that it's solid, it's not a cut, and it's not a join, it's a new body. And of course, the distance I know is 100 millimeters. So that makes it pretty much flush. And then, because the idea is that we don't want it to, like, once you push the pin in, it should be stuck there. With real hinges, if you do have to ever take the pin out of a hinge, you typically get a hammer and a small pick or chisel, and you can pop it out from underneath, or a screwdriver or something like that. So I'm going to click 100, and it's a new body. So I have my 3 bodies, the left hinge portion, the right hinge portion, and that pin. One last thing, just for a matter of aesthetics, and also to make sure that things don't get like pinched on each other, because again, the plastic does kind of change its kind of size because of the heating and cooling. And so what I'll do is I'm going to round off very lightly each of these sharp edges on these things. So I'm going to hide the pin for a moment. I'm going to hide one of them, and I'm going to select all the flat edges. So I'm going to choose this one. So there's one ring. I'm going to choose this one. I'm going to hold shift as I select them so they all stay blue, right? I'm going to choose this one, which is this one right here. I'm going to choose this one. That's 4, 5, 6. So 6 edges, not the actual faces. And then now I'm going to use the fillet tool, which is in our modify menu, or F on the keyboard. And there it is. And so since all 6 are selected, that's actually 12 edges. I don't want to overdo it, so I'm going to only put about half of a millimeter, so 0.5 millimeters. And so it does round them. And if I click OK, we can see that it does in fact round those edges. Oh, there they are. And I want to do the same thing for the other one. So now I'm going to hide body 1. I'll bring back body 2, and I'll do the same thing. Choose that edge, choose that edge, choose that edge, and the last one, all holding shift. So that's 4 of them. I'm going to use the fillet tool. Same thing. I'm going to go out of my way to do 0.5 millimeters. And there it is. All 4 are rounded. I'm going to click OK. And so now if I bring back body 1, they're still seamless, but that kind of rounded edge on each of them means that they won't hopefully rub together when we try to slide them along each other to place them. And then finally the pin, I would also argue that rounding off the edge of the pin will also stop it from catching on that inner ring. So I'm going to do that as well. So I'll hide both body 1 and body 2. I'll choose this part, and I'll also choose this one. So that's 2 edges, and I will do the same thing. Fillet one more time, and I'll do 0.5 millimeters. Click OK. So it is also rounded. Bring back all 3, and there's our final result. If I give it like a nice home view, there's our hinge. Right, so all 3 parts, and then we would print each of these separately, lay them out, and the final result would be hopefully a hinge that works. One last suggestion I'll make is if you do something like this, if you just say body 1, body 2, body 4, that's kind of unclear, so it would be really nice to name these things. If you double click on them slowly or right click and rename, you can do this. So I can call this like hinge left. I'll choose body 2, and I'll call this one, so again I can right click and rename if I like. I can do this one hinge right. And the last one, I'll right-click and do rename, and I'll call this pin. And so the final result is that we have our hinge. And of course, I could, for like if this was for a door or something, I could theoretically cut holes into this for screws to go through, but I'm not going to do that in this video. Right? So I hope you understood and saw some new things in this video, and you can use this to your advantage as you work on your projects. I'll see you in the next video.